video I'm going to be showing you how you can easily solve fractions. Actually, fractions are normally made up of a numerator and a denominator. So if you have something like this, this is actually an example of a fraction, a over b. This is the numerator and this is the denominator. So the one on top, numerator, the one below, denominator. So this is how fractions normally look like. we actually have three types of fraction. The first one is proper fraction. Then the second is improper fraction. And the last is mixed fraction. Well, these three types of fraction are completely different. For proper fraction, we have something like this, 2 over 3, where we have a lower numerator and a higher denominator. So when you have 2 over 3, or maybe something like 21 over 41, yeah, so when you have lower numerator and higher denominator, that is a proper fraction. Then for improper fraction, it's just the opposite. You have like 3 over 2 and 41 over 21. The numerator is higher, the denominator is lower. And most times this type of fraction ends up in mixed fraction. Mixed fraction actually has a whole number combined with a proper fraction. So for example, 1 over 2, or 2 5 over 6. Yeah, so this is actually the whole number, and this here and here is the proper fraction. So when you have a combination of the whole number and a proper fraction, that is a mixed fraction. So in my last video actually I showed you how we can apply combination of signs when solving expressions. We're going to be applying that a little in this in solving fractions. But before we get into that, I would like to show you exactly how you can first solve addition with fractions, then we enter subtraction with fractions, and multiplication, and then division before we enter serious calculations on fractions. So if you ask to add fractions, let me just put this here, addition of fractions. If you ask to add fractions, for example, 2 over 3 plus 1 over 2, one principle you need to remember here is the principle of LCM. The first thing you're going to do in adding fractions is to find the LCM of 3 and 2. LCM is actually lowest common multiple. Yeah, most of you already know that. And for you to find the LCM of 3 and 2, you actually most times draw a table, pick the lowest one first, and 2 can go into this, you bring 3 down, 2 can go into this one, then 3 next, and 1, 1. So the LCM will be 2 times 3, and it's 6. So that's how you find LCM. So the first thing you need to notice that when you're solving fractions, adding fractions, or subtracting between fractions, you need to apply LCM. So we're getting the LCM of 2 and 3, and that is 6. So the next thing you're going to do is you're going to put the 6 here and as a new denominator. Then the next step is for you to find, you're going to divide 6 by 3 and multiply it by 2. And that's the next step. So 6 divided by 3 is actually 2, and 2 times 2 is 4. Put 4 down here, we put the positive sign, and 6 also into 6 divided by 2 times 1. We have 3 times 1, that is 3. So we'll be left with 7 over 6. So the basic thing I'm just showing you is to add fractions, you actually need to apply. The first thing is to get the LCM of the denominators of the two fractions. Then after that, you put the new LCM, that's for the new denominator. Then also find, you divide the new denominator by the first denominator multiplied by the numerator, and do likewise for the next, and sum it up in the new numerator and get your final answer. So this we got 4 plus 7 over 6 equals to 7. 4 plus 3 over 6, we got 7 over 6. So that is for adding fractions. If you are given want to subtract, for subtracting fractions, definitely there will be a negative sign here. You just apply the same principle. You know that the LCM between 3 and 2 is 6. Then this into this is 2 times 2, 4. Then this divided by 2 is 3 times 1, and forget 1 over 6. So it's just the same principle. The only difference is the negative sign. Well, there's a little difference, or would I say much more difference in multiplication. Multiplication remains multiplication. So if we're asked to, we just change this to multiplying fractions. So if we're asked to multiply this fraction, 2 over 3 times 1 over 2. If you have what to cancel out here, you just go ahead and cancel out. But if you have nothing to cancel out, nothing to divide through, you just multiply through like that. So for this one, we have 2 and 2, which are easy to cancel out without any remainder or whatever. And so we have 2 here, 1, 2 here, 1, and we're left with 1 times 1, 1 over 3 times 1, 3. So that is when you have something to cancel out. But some of them, sometimes you don't have anything to cancel out. You could have, let me see, for example, 2 over 3 times 5 over 7. So you know that this one, there's nothing to cancel out here. 2 cannot cancel 7 out, and 3 cannot cancel 5 out, neither this, neither this. So you just go ahead and multiply. You have 10 here, you have 21 here. So that is going to be the answer. So you notice that these two are proper fractions. So when you get an answer that's an improper fraction, maybe it is 21 over 10 or 3, or maybe 3 over 2, or just an improper fraction, you notice that what you need to do is to change it into a mixed fraction. But for division, there's something you may not be familiar with, or you already know, but just to remind you, or for those that are new to fractions, for you to know, is that when you are dividing fractions, there's something you actually need to do before you get your final answer. So let's say 2 over 3 divided by 2 over 3. So if we have 2 over 3 divided by 2 over 3, the principle of mathematics and how it is done normally is you find the inverse of this fraction. You find the inverse of the fraction on the right hand side. So if you find the inverse of this, it's normally 1 over 2 over 3, which is actually 3 over 2. So the inverse of this is 3 over 2. And the sign will change to multiplication. So once the sign has changed to multiplication, we actually will get something to cancel out. So 2 can cancel 2, 3 can cancel 3, and everything is 1. Just write it well. Okay, everything is 1, and that is it. Let me just make it real. 1. So that is for division. Let me just give another example. let's say 5/6 divided by 2/3. So for this one, it's just the same thing. You find the inverse of the fraction on the right hand side. Just remember that is the principle. And once you find that, this sign will turn to multiplication. So you get 5/6 times 3/2. And this can cancel this 2. This can cancel this out. So you're left with 5 times 1, 2 times 2, which is 5/4. You notice this is an improper fraction because we have a larger numerator and a very small or a lower denominator. So we're going to be changing this to mixed fraction. I didn't mention how we change to mixed fraction, but I'm just going to show you. You normally use the long division method. So if you want to change 5/4 to mixed fraction, okay, now 5/4 to mixed fraction, use the long division method. You put 5 here, put 4 here. 4 into 5, you get 1. 4 times 1 is 4. You get 1 here. And if you continue, you get a decimal fraction if you really want to get the accurate answer. 5 divided by 4. But for you to change it to a fraction, you bring out this as the whole number, 1. This as the numerator, and this as the denominator. That is exactly how you get the mixed fraction. So just remember to apply the long division. For those who are new to changing to mixed fraction, that is how you can solve, change from improper fraction to mixed fractions. We're going to be looking at serious examples. Now we know how to solve ordinarily, that is, we can add fractions. Now we can subtract between fractions, we can multiply fractions, and we can divide between fractions. Remember, in dividing fractions, you have to invert the right hand fraction, then change the sign to multiplication. Then you cancel out, or you just multiply through. And if you have an improper fraction, remember to change it to a mixed fraction by using the long division method. So we'll be looking at serious examples on fractions in my next video. Thank you for watching as usual.